Hi, welcome to my presentation. I am Samacho Mangste, and the title of my presentation is Relevance of Network Topology for the Dynamics of Spiking Neuronal Networks. The motivation of our work emerged from the recent surge of publications on the area that emphasized the significance of network topology on functional advantage. While it's the case for small-sized networks with strong connectivities, we hypothesized that this may not be the case for large-sized networks with very weak synapses, for instance, spiking neuronal networks. To prove this hypothesis, we set three questions. The first one is obviously, does topology leave its own signature on the activity dynamics? Two, if not, which other structural feature better does? And three, what are the effects of network degeneration on structure and dynamics? So to answer these questions, we chose some models and we designed our own methods. So the first thing we did was generate 10 sets of 3 networks, namely small world, random, and scale-free network topologies. And then we designed 5 synaptic pruning strategies and 5 neurodegenerative strategies. Then we simulated the networks using a nest simulator. And as I illustrative in figure 2, we demonstrate what we did using a single network. So this is a random network which was simulated for 10 seconds. We put the raster plot at the top. And the second row shows the dynamical statistics and the structural statistics of some variables for this network. And the last row shows the change of these statistics with different degeneration techniques, especially in this case, it's five synaptic pruning strategies here. To put all the results together for all of the networks, we presented the result like this. So this is a bit compact figure. So in each subpanel, we see 2 halves. The left half corresponds to synaptic pruning strategy. The right half is for neurodegenerative case. In each half, you see 3 partitions, and these partitions correspond to Cosyne network, small world network, and scale-free networks. And in each partition, we see 5 subpartitions that correspond to the 5 synaptic pruning or the 5 neurodegenerative models. And then in each subpartition, you see the degeneration from top to bottom. So figure 3 shows the topological change with degeneration. And as we see, topology is not quite robust, especially in synaptic pruning strategies. And we did similar analysis for structural as well as dynamical descriptors for networks. And we notice here striking resemblance between effective synaptic weight with rate as well as irregularity. And also the variability in effective synaptic weight is reflected on the variability in the rate here. Apart from SW, we used multilinear regression to see which structural feature out of the selected 9 features stands out as the best descriptor to infer dynamics. So for that, we still see that SW is the best descriptor to infer a couple of dynamical features. Also, pairwise relationship also is depicted here in the 3 figures. We see nice linear kind of relationship for rate, synchrony, and regularity measures with that of effective synaptic weight. To conclude, effective synaptic weight instead of network topology stands out as the best descriptor to imply or to infer dynamical aspect